So, first question about bounds. All the measurements are given in centimetres and then they measure to the nearest millimetre. So what I would do is turn these into millimetres as well, just to make life easier. So we've got a 34 millimetres, we've got 26 and we've got 68. With any bounds question, start off by writing down the upper and lower bounds of every possible value. So nearest millimetre means we add on half a millimetre and we take off half a millimetre. So we do that for each of the numbers. And then we've got our upper and lower bounds. Question then says, so before we even look at the question, just write down all your bounds. By what percentage does the greatest possible volume exceed the least possible volume? So to find the greatest volume, we need to multiply the greatest sides together. So the greatest volume is those three sides multiplied together. So 34.5 times 26.5 times 68.5. So the greatest possible volume is 62,626.125, and that's in millimetres cubed. The least volume is obviously using the three least values times together. So the least possible volume is 57,661.875 millimetres cubed. And I know we wouldn't normally round to 3 decimal places, but because the question's not asking us to find the volume, I'm going to leave the answer to all its decimal places to start with. Now, to find out what percentage it increases by, so percentage increase is found by what is the increase divided by the lower value in this case, so the least volume, and then times by 100. So the increase is 62,626.125 take away 57,661.875 to find out how much is increased by, so that's 4,964.25. Divide that by the original, so the smaller value, and then we're going to times that by 100 to find it as a percentage. So divided by 57,661.875 and then times it by 100. So we find that it's 8.6% to 1 decimal place. Circle theorem question. So we need to show that this is an equilateral triangle. So to be an equilateral triangle, all the angles have to be 60 degrees. So alternate segment theorem tells us that this angle and this angle are the same. So that must be 60 degrees up there. Parallel lines rules from a few years ago. You can see I'm tracing the shape of a Z, which tells me that this angle down here must be the same as that angle up there, which is 60. Back to the alternate segment theorem tells me that that one and that one must be the same. And then I know the three angles in a triangle add up to 180, so therefore that one must be 60 as well. And also we've got a straight line here where those three must add up to 180. So each of those reasons I was given, the alternate segment theorem, the Z angle, and then the three adding up to 180, you need to list as your reasons. Probability tree. So probability Monday to Friday is 0.65, so probability no there would be 0.35, 0.8 here, 0.2 there, and 0.8 here, because it says it's the probability she works both days during a weekend is 0.2, and it says Monday to Friday to weekends are independent, so these aren't affected by these. Now if we were to fill this in full, we'd put yes, 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 no, no, yes, no, no, and then we do 0.65 times 0.2 to go here as 0.13, 0.65 times 0.8 would go on the next branch, 0.52, 0.35 times 0.2, 0.07, and then 0.35 times 0.8, 0.28. Remember, they should add up to 1. If they don't, you've made a mistake somewhere. Calculate the probability works every day from Monday to Sunday. So that's yes and yes, so that's 0.13. So by filling in the tree completely, we've found our answer already without having to do any further calculations. Probability. So the product of the numbers selected is 12. So the only way I can get that is if I have a 3 and a 4, or I've got the opportunity to get a 4 first and then a 3. They're the only two ways I can multiply numbers to make 12. So if we put these as probabilities, because these are the two probabilities that I can consider. So the probability I pick a 3 initially, there are 2 3s out of 6 cards. And then probability of picking a 4, there are 3 4s, but now there are only 5 cards to pick from because they're not replaced. Or means add, do the same for this. Now what's the probability to pick a 4 first? So we're going back to the beginning. All 6 cards are available. There's 3 4s out of the 6. And means times, how many 3s are there? There's 2 3s I haven't picked yet out of 5. This one gives me a probability of 6 out of 30. This one gives me a probability of 6 out of 30. which gives me a total probability of 12 out of 30, which does simplify, but you can leave it as that, that's fine. Second part says the sum of the two numbers is even. So if I want to make an even number, the way I can create an even number is by starting with an even number and getting another even number, because if I add two even numbers together, I end up with an even number. Or I can start with an odd number and get another odd number, which will also give me an even number altogether. So if we look at the probabilities, the probability I get an even number first, there are 1, 2, 3, 4 even numbers. So that's 4 out of 6, and means times. Now I've picked one of those even numbers, so let's ignore that one. There are now 3 out of 5 left to be even. Do the same with the odds. So the probability to get an odd number at first is 2 out of 6, because there's 2 of them. And then take that one away, there's only 1 out of 5 left to be odd numbers. So this one gives me a probability of 12 out of 30. This one gives me a probability of 2 out of 30, which combined then will give me a total of 14 out of 30 as my probability of picking two numbers that add up to be even. True or false statements. Selecting the first name on each class register is a random sample. No, it's not, because not everybody has an even chance of being picked. If the ratio of boys is 2 to 3 with girls, 10 to 20, that is not the same ratio. 2 to 3 would not be a ratio of 10 to 20, because that would simplify to a ratio of 1 to 2. So that's not the same ratio, so therefore that wouldn't be the correct committee. Telephone survey, the sample surveyed is not random. That is true. It is not a random sample, because if you don't have a phone, you can't be selected. Stratified sample always considers proportion. Yes, it does. That's the point of a stratified sample, is that you get the relevant proportions based on the full set of people. And a random sample means everybody has an equal chance. True. So, school council, which of the following shows how a truly random sample can be obtained? Randomly selecting people in the canteen? No, because if they're not in the canteen, they can't be picked. Randomly selecting people from those that attend the meeting? No, because if they're not on the meeting, they can't be. Randomly selecting people with a surname beginning with J? No, because if your surname doesn't begin with J, you haven't got a chance. Selecting every second pupil? Again, no, because the other people haven't got a chance. Giving each pupil a randomly drawing raffle tickets is a random sample. So, how many people who intend to vote for the central party? So we need to do the number of people who vote for the central party divided by the total of these numbers, and then times that by the 250 we want. So the total is 23456 plus 43244 plus 83124 plus 11782 plus 63789. So the total is 225,395. So we do the 23,456 divided by that number and then times that by 250, and that comes to 26.01. So we would pick 26 people who vote for the central party. Similarity. As soon as you see a similarity table question, draw the table. So we've got the small shape, the large shape, and the scale factor. And then we've got lengths, areas, and volumes. So in this question, we have a length of the smaller shape is 30, and we have a length of the larger shape is 45. The cost of painting the smaller one is £1.60. Now, if I paint something, that's going to require an area, because I paint an area, I'm not going to paint a length. And then I want to find out the larger area. So, find the scale factor of the lengths by doing 45 divided by 30. So that gives me a scale factor of the lengths of 1.5. I square it to find out the scale factor of the area, so that's 2.25. And then if I want to find the larger area, I do the smaller area times by the scale factor. So it'll cost £3.60 to paint the larger sign. Rotate the triangle. So, trace the shape. Mark the point minus 2, 3. So minus 2, 3 is here. So that's where I'm going to keep the pen. Little arrow to represent upright. 90 degrees anti-clockwise. So it's going to spin to the left once. So the new shape is going to go there. Go over the shape with quite a bit of force. And you should see the lines. Probably can't see them on the film, but I can see them in front of me. And that's where the new shape's going to be. And I probably would just point out that that was where I rotated it from. Just in case I make a mistake with the rotation, at least I've marked the centre. Scale factor of -2, -2, 1 as the centre of enlargement. So -2, 1 is this point here. So if we label the three corners 1, 2 and 3. So to get to corner 1, I've got to go right by 1, 2, 3. So I go right by 3. Scale factor of -2. -2 means I'm going to go left, and the 2 means I'm going to double it, so I'm going to go left by 6 instead. So I'm going to go 1, 2, 3, 4, 5, 6 from there. That's going to be my new corner 1. Corner 2 at the moment, I'm going right by 1, 2, 3, 4, 5 and down by 2. So I'm going right 5, down by 2. My minus sign means I'm going to go left and up, and the factor of 2 means I'm going to go 10 and 4. So I'm going to go left 10 from this point, and I'm going to go up by 4. So that's my new corner 2. I do the same with point 3. So point 3 I've gone right by 3 and then down by 3. So right 3, down 3. I'm going to go left and up because of the minus, and I'm going to double everything for the scale factor of 2. So I'm going to go left by 6, and then I'm going to go up by 6. 1, 2, 3, 4, 5, 6. That's the new corner 3, and then I'm just going to join up my 3 points to create the new triangle. So, go through the statements. 2 people only took part in dancing. That's already in. 5 took part in a reciting competition. So all of this circle is worth 5. No one did reciting and dancing. So reciting and dancing, nobody did. So there's 0 in there. So we've done that statement. 3 took part in both the singing and dancing. So singing and dancing, there were 3 in there. So we've done that statement. 9... Oh, sorry, I misread one statement. 5 only took part in reciting. So that's the 5 down there. 9 took part in reciting. So this whole circle here is worth 9. So if I've got 5 and 2 zeros, there must be 4 in there. 22 took part in singing. So all of these must add up to make 22. So I've got 7 so far, so there must be 15 left. What is the probability that the person only took part in singing? So there were 15 people who took part in singing only. And then altogether, there were 15, 18, 20, 25, 29 people altogether. So 15 out of 29 is the probability that they picked only singing.